Hi everyone, welcome to my YouTube channel. Thank you so much for watching my first video. I hope you all liked my content. I request you all, if anyone not subscribed to my channel, please subscribe now. By that, you will get notification for every new video I uploaded. Thank you. Let's start today's session. Today is our day 2 in our Ab Initio training course. Let me share my screen first. Okay, before entering into our day 2 course, I just want to recap our day 1 session. By that, if anyone missed or not watched my first video, they can understand what are the contents we discussed in our day 1 course. In day 1 course, which is our introduction course, we discussed what is Ab Initio, why we use Ab Initio, what is meant by ETL process, Ab Initio architecture, what is a sandbox, what is a project and its structure, and we also discussed different terminology used in Ab Initio. So let me give you a brief recap of day 1. What is Ab Initio? As I already said, Ab Initio is an ETL tool which is used by business organizations all over the world today for data migrations, data transportation, data mining, customer relationship management, online analytical process, etc. Why we use Ab Initio? Ab Initio is a more appropriate tool for batch or real-time data synchronization between applications where a large amount of data is being moved around between applications and the data must be transformed and then loaded into other applications, which shows us that whenever there is a need to build a large amount of data enterprise applications, we use this Ab Initio ETL tool to process real-time data or batch data. So even we can synchronize data between one or more multiple applications. And what is meant by ETL process? So as we discussed earlier, ETL stands for extract, transform and load, and which we use to perform data integration process that combines data from multiple data sources into a single consistent data. So now let me go through this Ab Initio architecture once again. As I already said, Ab Initio mainly contains 3 components which we interact daily while we working on Ab Initio. The first one is graphical development environment, second one cooperating system, and the third one enterprise metadata environment. As I said before, graphical development environment, which is also called as a GDE, is a tool which is installed in our Windows machine and where we develop all the Ab Initio graphs to build applications. And cooperating system is heart of Ab Initio, which is used to process all the graphs and execute, and it also interacts with different data sources and execute all the graphs which you have developed. An enterprise meta environment is a repository. We can say it as a version controller where we used to store all the data. And next, we also discussed what is a sandbox. As I said, a sandbox is a workspace where we create our Ab Initio projects and store all objects and related files in a single directory, in a tree structure, and treated as a group of purpose of version controlling, navigation, and migration. Okay, I hope you all understood what we discussed in our day 1 session. Now, let me explain what we are going to cover in our day 2 session. So you can see on my screen, these are the topics which we are going to cover on our day 2 topic. So we are going to see how the graphical development environment is I will give you a brief overview of how the GDE looks like, and we are going to discuss how we are going to set up a configurations between our GDI, our GDE and cooperating systems, and we are going to create one basic Ab Initio project, and we also know about what is a graph, what is a component, types of Ab Initio components, and finally we will design a simple graph, and we will have a brief introduction about a DML. Okay, now you can see X once you installed in the Windows machine. You can see all tabs over there: file tab, edit, view, insert, project, run, debug, test, settings, window and help. And you can see a different layouts there, where you can see a canvas overview. In that overview you can find the small canvas where how your Ab Initio graph looks like. And similarly you can see a sandbox view over here, where your project will be loaded, and you can see all the project structure in this sandbox overview. And again, under down here you can see a organizer, your organizer, where you can find all the Ab Initio components, where all the Ab Initio components you can use to build Ab Initio graph. And this is an application output. At the bottom left hand corner you can see, while you run an Ab Initio graph, you can find all the log and how it is executing over here. So finally you can see a different layouts where how the GD looks like. Let me explain each and every tab how it looks like. So the first one is your file tab, where you can see new, to create a new graph, open to open an existing graph, close if you want to close a graph. If you want to close, you can use all the close L, save as. So these are all basic operations which we perform in our Ab Initio graph creations. As well as you can see a versions, where you can see if your graph have a different version stored, so you can find out how many versions your graph having. If you click on this, it will show you the list of versions available for that particular graph. And the next one, dependencies. That means if you want to know what are the dependencies, or what are the graphs are dependent, or what are the objects that are dependent on this Ab Initio graph, you can find through this dependencies options. And the second tab is your edit tab. In this edit tab you can see the parameters. These are the main things which we can discuss later, what are the parameters, how you define parameters, and why it is necessary, and when we create these parameters in our Ab Initio graph. And we can also see the script, subgraph propagations. So I am going to discuss these things once we start our build. And the next, another tab we are going to see is the view tab, where you can see enable all our different tools, functions, or overviews, hierarchy views, sandbox views, whatever you want. You can keep everything over here, and you can select each and every layer, and you can choose to display in our GDE. And the next tab we are discussing is our insert tab. So insert tab is mainly used to insert any Ab Initio component in our graph. Either it can be input file, output file, input table, or if you want to write any text, you can use this legend, or you can select more components from this component tool. Okay, and the next thing is run tab. In this run tab you can see a start over here. So after completion build of your graph, you click on the start button, then automatically the graph start executing. And also you can see another options like wrapper script, input values and reset input values, select input values, refresh environment. So these all options we will discuss in our upcoming classes. Okay, now the next topic is how we are going to set up Ab Initio configuration from our GDE to cooperating system. So now why we need to set up this configuration? Okay, let me explain why we need this configuration. As I said, we install GDE in our Windows machine, and our operating system will be most of the organizations use either Unix or a Linux. So now you are understood that both the softwares installed in different operating systems. That means GDE installed on Windows and operating system installed in Unix. So how a GDE knows where the operating system installed, on which server it is installed? So to establish a connection between your Windows GDE machine and your operating system, you need to create one connection string by specifying to which server it needs to connect. For example, let's say if I give a postcard to a postman and ask him to deliver, okay, then the first question the postman will ask you is to which address I need to deliver this letter. That means the address, the to address is necessary for this postman to deliver our letter. At the same way, to connect GDE, there you need to specify a host connection setting, which is your to address. That means you are telling your GDE to connect to a specific Unix server where your operating system lies. So here you can see the settings tab, yeah, and you click on this manage connections. Once you click on this manage connections, you can see this host connection tab. There you click this new button. Once you click your new button, it will open a pop-up. It will ask you to enter your host connection settings, where you can mention your name, the connection name, and the description, to which server you are connecting, host type, whether it is a Unix or any other type of host, and you need to provide your host name here. That means your server address where your operating server lies, and you need to mention about which connection settings, connection method you need to use to connect to this server. Let's say SSH method, that is secure shell connection. And you need to mention your user, that means to and password, which specify which user you need to connect to this server. And you also need to select the cooperating system version, where currently I am using v402-04. So this is my cooperating system version. So every organization uses different cooperating systems as per their availability. So like this, once you done this host connection settings, then your connection method will establish a connection between your GDE and your operating system server. That means whenever you develop a GDE and press execute button from the run menu, then automatically the graph will start executing on that particular operating system in that server. Okay, I hope you all understood why we need to do this Ab Initio setting configurations. And then next, the basic thing which before we develop a graph is a project. A project I already told you that a project is a sandbox or a workspace where we store all our Ab Initio related files into a tree structure within a different folders. Okay, so this Ab Initio is a collection of Ab Initio objects related to one particular functionality. Okay, so now if you can see the step 1, you have to go to this project menu. Okay, and then select create sandbox option. Once you select this create sandbox option, it will open you this menu. So here you need to specify which project type you are going to create, whether it can be private project, whether it can be a public project, or a basic sandbox. So I will explain what are the different types of projects in our next session. Okay, let's move on. So here it is, you need to mention the name, that is what is the project name in this relative location. That means you can see on my step 3 screen, your project has been created with the name of Ab Initio underscore practice. The same name I have given here in the relative location, and also in the root directory you need to mention on which path of your cooperating system your sandbox needs to be created. Once you give all these details and click OK, automatically a project will be created and loaded into your GDE. Okay, let me explain once again. You have to go to the project menu, yeah, and select create sandbox. Then you will see one menu where you can select the host connection. That means which server you need to create your sandbox, and next you need to select which project type, which Ab Initio project type you need to create, and then you need to specify the project name. Here I gave Ab Initio underscore practice, and then select your directory, root directory, or the location where your project needs to be created, and then click OK. It will create you this proper Ab Initio private project and it will be loaded into your sandbox. Okay, so let me give a brief introduction about what is a graph and what is a component. You can see on my screen a graph. The graph is the most important unit in Ab Initio development. Okay, a graph is a picture that represent various process stages of a task and streams of data. They move from one stage to another. So this graph basically contains series of components which is used for one particular functionality. Okay, that means let's say we want to read data from a file and we need to load that data into one table. Okay, so we need to use components like input file component to read data, and output table, which is a table component to load data. These are the building blocks for a graph. So you can see on my screen what is a component is. Component is a building block of a graph. This component connect to one another component through a set of ports. I will explain what is a port. So a port is a part of a component, okay, which stores the DML of a data. That means the representation of a data which is either coming into the component or going out from the component. Okay, so this port is a connection point for input and output to a component. Okay, some ports connect to single flows and some ports connect to multiple flows. Okay, we will discuss what the port is in next slide. Okay, so before going to discuss about how the graph and how the components, okay, let you can see the types of Ab Initio components available in our Ab Initio. So there are different types of components available in our Ab Initio to perform different types of functionality. You can see continuous components to perform real-time data, to read data continuously, okay, to whenever there is an application you need to create to load or to read a continuous data, we use these continuous components. And the database components, where if we want to connect to any tables like Oracle, SQL, Azure, Hadoop, so we are going to either use these database components to either to extract the data or to load into a data or to run some updates into a database tables. And dataset components, basically the dataset components is also similar, like to read input files or to read particular data sets. Okay, and you can see other components: interchange components, internet components, metadata components, partition components, sort components, transform components, translate components, validate components, and XML components. Okay, so in our future classes we discuss each type of components and we go through each component one by one and how they are used in our Ab Initio graph to achieve our functionality. Okay, this is just an overview to show what the organizer is and what type of components presented in our Ab Initio. Okay, so we use these components to perform a different types of functions. Let's say if you want to sort a input data either in ascending or a descending, you go and use this sort component. If you want to filter any data, you can use this filter component. If you want to join two data sets, you use join component. So like this, if you want to do any mapping changes or a transform functions, you will use this reformat component. Like this, for every functionality which we perform in Ab Initio, we use different components. Okay, that we go through each and every component in our next lessons. Okay, now let's design a sample graph. Okay, so let's take a sample requirement and design one graph. Okay, now you can see on my screen, okay, we have one input, that is we have one employee information data which have fields employee ID, first name, last name, and location. And our requirement is to create new employee information, okay, where we have to add a new field which called as full name. Okay, and then they have given a mapping criteria for our requirement, how we will derive the field, the new field full name. Okay, so they have given here like we need to use first name from here and the last name from here, and we need to concat this first name and last name and populate this data into our new field called full name. Okay, you can see the input data, a sample input data of this employee info. Okay, so we have employee ID 101, first name Ravi, last name Manepalli, and the location Pune. Like this, another second data 102, Krishna, Chella, Chennai. The third record we have 103, Srikanth, Daruri, Hyderabad. So what the requirement is asking us to do is read this input data, okay, and create one transform, okay, which to create one output file. Okay, in that output file, okay, we need to keep all employee ID, first name, last name, and location. Okay, and with this we need to add one more extra field, that is full name. Okay, how this full name needs to be is to use our input first name and our input last name, concat both and copy this data into full name. Okay, as you many of you know our addition program in your C programs. Okay, we take first number, you take second number, you add first number plus second number and perform an addition. The similar way they are asking us to concat first name, last name and derive a second name. Okay. Okay, this is how we design a sample graph. You can see over here I have taken input file component, okay, to read all the employee info data, and I used reformat component where I have written a logic to read this input data fields first name and the last name and concat both the first name and last name and create your final output file. Okay, so the data you can see it is a single flow data where the data is flowing from this input file to reformat. Okay, this is step 1, and then it will perform all your transformations here, and the data after transformations it will go here and create your final output. This is how you design your sample graph to satisfy the requirement. Okay, so you can see I have already given a legend over here, a graph to read employee info data and create a new field full name by concatenating first name and last name. Now let me open each component and show you how you need to code to create this graph. By that it will execute properly in your GDE. Okay, so you can see there are steps I have given here. Okay, let me show you each step, okay, one by one. So you can see a step 1. Okay, in step 1 I have taken a input file component from our organization. Okay, in input file components there are two. You can see these are the tabs. If I right click on the input file component and open the properties, okay, you can see the tabs presented here for this input file component. The main tabs which we need to use are this data tab and ports tab. Okay, so what is a data tab? In this data tab you need to specify your location of your input file. Okay, that is where your employee info data situated. That is, here you can see my employee info data file is located in my project directory and data folder. Okay, so here I need to mention the location. By that this input file go and search in this location and load this employee file for execution. Okay, and the second step you can see over here there is another tab called port, right? So I already told you in the previous slide what is the port. Port is an entry or an exit connection between two components, okay, which specifies what type of data it is having or it is sending from one component to another component. Okay, now we have taken input file component. That means here this is a record format which specifies how my data is represented in our input file. Okay, as you can see in my previous slide, here you can see how our data looks like. Employee ID, comma, first name, comma, second name, comma, location, and second record starts from the new line. So this is how our data is. So we need to specify this DML, okay, based on how our data is. Okay, if you see here, I have specified my record format. Okay, my record, that is each line in my input file, contains one field employee data which is separated with comma and it is a number, so I have given as a decimal. And the second field is first name, which is also separated by a comma, and the data type of first name is a string. Like that, last name and location, which is the end of my record. So this slash n specifies the end of the record. So this is how you need to write a record format. Okay, you need to specify which data type that field is and how you separate each field. You need to mention a delimiter and provide all the fields one by one, how they are presented in your data. Okay, so that means if you know how the data is, you can write in the same linear phase. At the same way, if you want to create a new data, you have to write how you need to create that data. Okay, so if you can see in my reformat ports, okay, I am adding our new field here, full name, that should come from after last name. Okay, just show me once again. So this is our input data which contains employee ID, first name, last name and location, and this is our final output after our transformation, which contains employee ID, first name, last name and full name, and also your location. Okay, I hope you all understood this. Once you write that transform reformat, then you need to go and select the right click properties from the reformat, and there you can see a transform parameter and click new. Then it will open you to write a reformat. So here you can see how I have written a code to create our new field. Okay, the fourth line, out dot star equal to in dot star, which means all my input, which is employee ID, first name, last name, location, should copy as it is. How the data is in input, it should copy as it is to the output. But for the new field full name, it should do a string concat, which is first name, and I am giving a space, okay, just to separate first name and last name. Okay, this is how you perform a reformat operation, which is also called as a transform, to achieve our requirement. And the last component is our output file. In output file, you need to mention in which location you need to store your output file. Okay, now I have given here in my project directory data folder. The new file needs to be created, employee info underscore final data. Okay, so you can see over here my input file is employee underscore info.dat and my output file is employee underscore info underscore final.dat. Okay, this is how you write Ab Initio code to create this employee graph, to read a data from the input file and to perform a transform and to create your output file. Okay, once you done coding for this Ab Initio graph, the last step would be execution of a graph. Okay, let me show you how to execute this Ab Initio graph. Okay, so as I told you that to execute this graph you have to go to this run menu, yeah, then click on this start button. Once you click on the start button, the graph will automatically start executions. Okay, you can see on this picture where the graph executed and completed. You can see from input file it extracted 3 records, and through the our port connection it sent this 3 records into this reformat, and it performed all the transformation, the string concat, and written all these 3 records into our final output. Okay, now you can see the data, how the Ab Initio process. Okay, this is the data in our input file where you can see employee ID, first name, last name, and location. Okay, and this is our output file, final file, which we created: employee ID, first name, last name, and full name. And you can see the data is concatenated here: Ravi space Manepalli, Krishna space Challa, Srikant space Daruri, and you can see location word. So as you remember how we code, we wanted to transform all the input fields as it is, that means employee ID, no change in data of existing fields. The only requirement is to add your new column, which is full name. Okay, this is how you code in Ab Initio. Okay, for each and every requirement you need to understand how and what is your input is. Okay, and you need to know how your input data looks like how the data is, and which data type and which data structure it has, like it is a table structure, if it is a comma separated, or whether it is separated or a fixed length. So before starting your Ab Initio graph you need to understand how your input data looks like and how it is available for you. Okay, then the next thing you need to know is how you need to create your output. So how we need to create output, that you will understand by seeing your mapping conditions. Okay, so once you are clear with your requirement, what should be my input, what should my output, how I need to bring my input to output. Okay, so once you know what functionalities you need to derive based on your given mapping conditions, based on those mapping conditions you choose which component you need to use. Okay, so the same way I design here, like my input is simple, I need to use employee info data from one file, that's why I choose input file components. Later I need to perform a simple transformation, that is to create one new field which is called a full name, and this full name needs to be a concatenation of my input data, which is of first name field and a last name field. Then after this transformation I need to create my final employee field. Okay, that is how I wrote my transform function over here. Yeah, so I use this built-in function string underscore concat to concat this first name and second name. Okay, so the major things, the major points you need to remember is to write the ports, that is to write your record format, how your input data is. You need to write a proper record format, like how your data is. If there is any mistake in your DML, okay, in your record format, the data is not described properly, your GDE will not process data correctly, it will fail your graph. Okay, so every time be cautious while you writing your record format. Okay, this is the end of our day 2 session. I hope you all enjoyed my session. Okay, if you have any queries, if you don't understand anything, please comment in our comment section. By that I can read and give answers to your queries. Okay, once again, thank you for watching my video, and please don't forget to share, subscribe to my YouTube channel. Thank you.